Hello students, as we reach the fag end of this course, we will now look at what to expect in the days to come in the 21st century. We will begin today with a series of 4 presentations on search for a new architecture. What are we searching for? What are the questions that will confront Indian architects and planners in the days to come? What are the critical issues that are important for students of architecture to learn as we move forward in the coming decades? You already know that the world is changing very, very rapidly. And the biggest thing that is really changing the world is digital technology. You and I may have read about it, you may have studied in your history books about the great impact of the Industrial Revolution in the 19th century and how it totally changed the way of life in every possible way. And how that Industrial Revolution then spread all over the world, starting from England and Europe, and the tremendous impact it has had. All the industrialization that we see is a consequence of that beginning that was made in the 19th century. In a similar fashion, we can talk of the digital revolution today, and it is having the same kind of impact, a very similar impact as Industrial Revolution had done. It is completely revolutionizing the way we work, the way we study, the way we interact with each other, the way we communicate, the jobs, the kind of jobs we have, socio-cultural, the socio-cultural interactions that take place, the economy of our country or economy globally, how trade is done between nations. Today, anything you want to buy is as far away as a click away from you. You can buy anything from anywhere at any time, 24/7, just by a click of an app on your cell phone or your tablet or on your laptop. And this technology that is so rapidly changing is going to become even more radical in the days to come. But along with that are coming up many, many serious problems that we will have to deal with. One of the problems, for example, in the case when we look at the construction sector, is the increasing urbanization. Now, the same thing happened during the time of the beginning of from the time industrialization set in, that there was a movement from land to cities, to urban areas, and this momentum has only increased as time has passed by. For example, in India, the urban population in 2001 was 286 million or 28.6 crore people, and this is going to shoot up to around 59 crore or 590 million people by 2030. There will be at that point in time approximately 40% of our population. Tremendous pressure is coming on urban construction, particularly residential construction. Now, it's obvious that increasing construction activity, though necessary for a growing economy like India, is going to lead to some repercussions. It will require increasing amount of materials, that will require increasing energy to manufacture them, and that increasing energy will result in increasing carbon emissions because we use non-renewable resources like coal, for example, to produce the energy needed to manufacture the materials. As a result of because this is a global impact, and this is not only happening in India, it is happening all over the world in both industrialized and industrializing nations. Carbon emission rise will lead to rise in global warming. You might have read about it, heard about it, and it is said that if there is a 1.5 degrees centigrade rise in temperature from pre-industrial levels, that means right at the very cusp when Industrial Revolution actually began, that very point, from that moment, if the temperature rises globally by 1.5 degrees Celsius, there will be a near irreversible change in our climate system. Now, you might think that this is doable, we can control it, but please understand the real problem. The real problem is that recently you might have heard of COP26 that was held. And around that time, the UN came up with a report and they declared what is called as Code Red, which means that the global temperature is likely to rise by 5 degrees Celsius in the next 20 years. So that totally throws out of the window the 1.5 degrees Celsius pre-industrial level rise, because this is way too much. The impact is going to be extreme heat waves, drought, flooding, melting glaciers, rising sea levels, and this is already happening. Floods, for example, in Germany that I've never heard of before. Recently, there have been massive floods in Pakistan, in regions that normally have never really seen that level of flooding. Droughts are happening in parts of the world where there were never any droughts. Forest fires are happening with increasing degree. And as a result of this, there are rapid and far-reaching changes needed in all sectors of economy. One of the sectors is the one we deal with, you and I, that's the construction sector. And India, for example, is the third largest emitter of carbon in the world after the US and China. Now, of course, comparatively, it is much less as a nation. China is at 27%, India is at 7%, but that's still huge. Now, carbon emissions in buildings, that which concerns us, is primarily because of two things. One is in constructing the building, and the second is in operating the building. When we construct the building, when we use materials that are manufactured by using energy leading to carbon emissions, that is called as embodied carbon emissions. That is the carbon emissions embedded within the building because of the materials. The second is operating carbon emission that happens as a result of operating the building, air conditioning, heating, digital equipment, lighting, all fixtures, etc., electrical fixtures, and the total carbon emissions from both these works out to be 38%, about 28% from operational and about 10% from embodied. Now, this is the figure that has come up in the 2020 Global Status Report by United Nations Environment Energy Program. Now, therefore, both these have to be targeted in order to reduce this carbon emission. I personally work in the area of embodied carbon, but there are a whole lot of people who are focusing a lot of attention on operating carbon. In this particular presentation, we will tell you the focus that we will be looking at is on the reduction of operational energy and thus operating carbon. Now, there is sometimes an overlap in the usage of the term sustainable and green. Sustainable building and green building. Of course, there is an overlap, but green building happens to be a subset of sustainable building. A sustainable building or a sustainable environment includes both environmental, social, and economic sustainability. Green buildings primarily are focused on environmental sustainability. Therefore, if this is sustainability, it talks about both three things: acceptability, equitability, and viability of whatever technology that we are trying to use for the sake of environment, for the sake of people in general, the social responses, how can we prevent damage to the social structure, and how it can be economically profitable, because any venture that we take up to bring about sustainability must be an economically viable model. Now, you must have heard of Sustainability Development Goals, SDGs as they are normally called. United Nations General Assembly in 2015 came up with 17 SDGs to target sustainability in all sectors of the economy. And the impact of green buildings is associated with 9 of these SDGs, as you can see in this slide. You can read it up later. Now, green buildings are focused on 3 important things, the SDGs that are linked with it. So there are 3 things that we focus on. We focus on reducing the negative environmental impact through design, construction, and operation of the building. The picture that you see here is that of the first platinum-rated green building in India, and continues to be one of the greenest buildings in India, and that is the IGBC Godrej building in Hyderabad. It was designed by Karan Grover. Now, the green buildings are to use a simple term, I'll use the word climate responsive buildings, because green talks about many more things. It talks about water efficiency and resource efficiency, etc. Because that all of it forms the ambit of environmental sustainability, my focus is going to be on energy and the reduction of energy that we can do through buildings, and thus leading to reduction in carbon emissions. Now, why do we need climate responsive buildings or energy efficient buildings? In the earlier days, as I've talked about when I was talking about critical regional buildings, I was telling you, and right from the beginning, we had looked at it, and I had repeatedly mentioned to you that climate is one factor no architect working in India can ever neglect. It could not be neglected by the people who came earlier than the modern times, earlier than even the British, the Mughals. All of them had to put in the factor of climate, factoring climate into their buildings. The British had to do that, Lutyens and Baker had to do that, and other British architects had to do that, Corbusier and Louis Kahn had to do that, and then Indian architects who followed them with modernism, they also had to do that. Even when A.P. Kanwinde brought in and Habib Rahman brought in Bauhaus functionalism into India in its probably purest form, they still had to modify that Bauhaus concept for Indian climatic conditions by providing brise soleil and sun breakers, etc. And modifications had to be made. Now, so as we carried on, so many buildings that we have seen in this present course, we were looking at, I was constantly repeating the fact that there was a limitation with regard to technology, with regard to materials, with regard to resources in general. So, therefore, the architects could not design buildings that were, for example, centrally air conditioned, because that kind of financial resources were very limited we were very constrained in our resources to have buildings like that and run buildings like that. And plus the kind of building technology required, the kind of materials required to produce these buildings in an economically viable manner was also severely constrained at that time. Therefore, because of this constraint, the architects were compelled to design their buildings with passive controls. That means the building has to be climate responsive, so that the climate will help in providing you occupant comfort, thermal comfort, daylighting without glare, etc., etc. So many buildings we have seen of Korea, B.B. Doshi, Anant Raje, and so many other architects. So the focus then was that we don't have the resources, therefore we have to make our buildings climatically responsive without the need for mechanical controls, which were severely constrained. Now, when we come into the 21st century, so we are talking about a pre-liberalization period. Post-liberalization, when India's economy opened up, we have the highest GDP rise in the world. We are a tremendously fast-growing economy. We are now one of the strongest economies, rising economies in the world, and we are one in the overall global economic setup. A very important role we are playing right now. As a result of that, we have the required technology, the materials, the resources, the facility, the economic weight to create buildings that are actively controlled, centrally conditioned. A lot of corporates have entered into India, and they have given us that global image with their buildings. And so for a period of time when there was rapid growth in India, these buildings were built, but now what has happened is, though we have the resources, the technology, the materials, etc., we suddenly realized, as everybody else has realized across the world, is that these buildings are energy guzzling, carbon emitting buildings. Not directly, but because of the energy they consume. As a result of that, sustainability today is not a choice, it is a necessity. India has targeted itself, it's committed itself that we will bring down our carbon emissions to about 50% of the current levels by 2030 and become carbon neutral by 2070. I mentioned this fact earlier also. Now, this is an immense target. Please understand this and get it clearly in front of you today. Tomorrow's buildings will be driven by technology. They will be driven by issues of resilience, climate adaptability or sustainability. They will be driven by digital technology. As a result of that, it is vital for you to build your foundation in more and more technology. I am not saying that you have to do advanced level courses. But I'm saying that you have to have a very good idea of how buildings are evolving technically. Now, so from the post-liberalization era, what has happened is that we are now designing sustainable buildings because of the necessity of carbon neutrality or lowering carbon emissions. And therefore, we are again going back to passive controls. But the amazing thing that has happened is the very technology that is causing these problems is also giving us the solutions to solve these problems. And what is that? That we can now take from traditional knowledge systems and convert them with highly efficient mathematical technical models and apply them in our buildings. Let's look at a couple of examples. This is Kala Academy. Charles Correa did this building in Goa, empirical design of pergolas for shading. But here in the British school, by morphogenesis, the pergola has been designed computationally. This is much more efficient and much more mathematically correct in terms of the kind of shading and comfort it provides. Similarly, when we look at the jali work that we saw in India International Center, as a case study that we've studied, the work by Stein, the jali work is very efficient for thermal comfort. It does a great job in letting in the wind blow in faster because of smaller apertures, increasing wind velocity, providing that cool breeze entering into the building. The accordion doors open up. You can look back on the slides, I told you that, and how the entire room turns into a deep veranda, etc. Now, the same concept applied by Sanjay Puri in 72 screens, a building we'll study, is again done computationally, which is a far more efficient jali, but it's a modern jali. So what has really happened is, it's an amazingly wonderful marriage of traditional systems and modern technology. And that is producing the modern times critical regional building, the critical regional buildings of the 21st century. Sanjay Puri is one of those people driving that change. He was born in 65, graduated from the Academy of Architecture in 88, apprenticed with Hafiz Contractor, and started his self-practice in 1992. He promotes innovative design solutions that are contributing to sustainability and spaces that are meant to revolutionize the way we experience them. He says you have to encourage people to think beyond the existing parameters, and so he has done very interesting and iconic buildings which have come up, which are coming up in housing, in office buildings, retail, entertainment and private houses. One of the houses that he did in 2011 was a courtyard house, very famous house done in Ajmer by Sanjay Puri. Now this picture shows you, the slide shows you the difference between a modern Indian courtyard house and a traditional courtyard house, Kerala courtyard house for example. And this is a vernacular space interpreted for the modern house. The principle is the same, but the idea is interpreted in terms of modern architecture. And that is why it is so important for us to focus on traditional knowledge systems, not to neglect them. That knowledge that has evolved, that our forefathers picked up over centuries of learning in a particular region through hit and trial, experiences, etc., is a vast source of information of principles and concepts that can be applied in modern houses. For example, let me give you an example. Classical architecture, Greek architecture talks to us about classical symmetry. Now, classical symmetry is a principle. It is not just there for the Greek temples. Any building can adopt a classical symmetry, and it has been adopted widely by so many architects. So that is one way in which we can just pick the principles and adopt them to modern buildings or adapt them to modern buildings. Now, in the courtyard house in Ajmer, Sanjay Puri does one thing very differently, and that is the rooms are not inward facing towards an internal courtyard, the rooms are outward facing towards the landscape. So here if you see, this is a standard courtyard where all the rooms are looking into the internal courtyard, but here in his house, as you can see in this model, all the rooms are facing towards away from the internal courtyard. Now, if I compare his house with a very vernacular courtyard house, this is an example from Udaipur having a central courtyard and smaller courtyards. So this is a 3,000 square meter house, the courtyard house, and it is planned around the central courtyard, and then there are smaller courtyards spread throughout, and there are also small water bodies around the courtyard. Very simple principles of green and blue infrastructure to cool the building and may keep it thermally comfortable. So this picture indicates the approach, and this picture indicates the composition of the variously proportioned concrete volumes, and they are amazing. Architecture in its form and aesthetics is not neglected in technology. That is a statement I mentioned earlier to you, that science is not leading to bad buildings, bad aesthetical design, bad aesthetics in buildings. In fact, it is contributing to better aesthetics, because we can do with our buildings things that would not have been possible before. So here in this building, for example, this is on a monumental scale, and within this one double height room is accommodated 2 floors at the rear of the house. So this is an amazing form that he has generated out of refined beton brut. Here it is the views of the landscape from all sides, and it seems as if the house is growing out of the ground, and it is a fortress-like mass. Now it responds to extreme climatic conditions of its location, that is Ajmer, where summer month temperatures can rise up, is an average of 45 degrees Celsius. So the passive strategies that he employs are, one is earth berming. So by providing these earth berms on the side of the house, he provides natural insulation of the earth. In the ground floor, for example, most of the spaces are linked to the internal courtyard and smaller open air spaces, smaller courtyards, and he also creates this integration with the greenery into the house. So there is greenery all around, and then is greenery within the house, and all over spread all throughout the house in smaller and bigger courtyard spaces. On the first floor, the bedroom groupings revolve around the internal courtyard, and what he has is this open corridor that is leading to these bedrooms. So if you look at these spaces, this courtyard is connecting them all. Now, this is how the effect of the courtyard starts taking shape. The cool air moves in, the hot air rises and cools this place, but he does the same thing very interestingly on the outside also. Because of the earth berm, it acts like one of the walls of a courtyard, and thus this space also functions very similar to an internal courtyard. Then he talks about shade and shadow. This shows you how shade and shadow impacts the building in summer, in morning and evening, and in winter, morning and evening. And you can see that the building does a lot of, if we just keep aside the winter, because there it will not be important, but in the summer, as you can see, at a particular time, because this is a shadow pattern of a particular moment of the day, it shows you that how much of the house is mutually shaded by its form, and how much of shade is available to us. Then the gardens are protected with having privacy created because of the earth berms. So the earth berms are not only serving the function of providing natural insulation, they are also serving the function of providing greater privacy to the occupants. Then there is the passive strategy, the corridors themselves. They are linked they link the interior with the exterior. They provide cross ventilation to all the areas of the house, just as it would happen in a standard courtyard, in a standard corridor in a courtyard house, and they are screened to block out the glare of the sun. They allow diffuse light to enter into the interior spaces of the room, interior spaces of the house. Now, sustainability comes through the use of local materials, which is another thing that happens in green buildings, that the materials have to be sourced within a particular diameter of the project. Here, the advantage is that he is using exposed concrete. The advantage is that the house is in close proximity to a cement plant. So the massive amount of cement required to build this big house could easily be sourced from the cement plant. Now the verandas. The living spaces are oriented to capture the views from all sides via these deep verandas. So this is what I was talking about, the veranda looking out towards the outer areas, and these verandas serve as transitory spaces between the inside and the outside. They provide that kind of a barrier as you move from outside. Then there is the veranda leading into the room, and thus reduce indoor heat gain and increase the overall energy efficiency, because when we reduce heat gain, we reduce air conditioning loads, and thus efficiency in terms of energy increases. Now, passive strategies in conclusion for the house is that the concrete structure itself works as a thermal mass, and thus it is able to retain heat within itself in the daytime, and when in the night time in the desert climate it becomes cool or colder, then it releases the heat and makes it comfortable. The principle of traditional Indian courtyard house to tackle heat and create a cooler environment and cross ventilation is there all throughout the house, and also there is increased privacy along with the provision of shade for the occupants. I've been through it in a very summarized manner. You can study this in great detail. It's available online and it's available in literature. This shows you how principles of traditional courtyard houses of Rajasthan have been applied here. When you look at the house, it doesn't at all seem like a traditional dwelling. It is a totally brutalist, refined Beton Brut house. But when you look at it closely, you start seeing the traditional principles behind it. Then there is a 72 screens project by him in Jaipur in 2013. And this is a corporate office headquarters which is 6-storied high, located in Jaipur. Average temperature goes from 30 to 50 degrees Celsius most part of the year. The main office areas are spread on these 5 levels. And below that is the ground level, and underneath the ground level is the basement car parking. Now, the primary focus of design was to minimize heat gain. Now, these case studies, the first one, the courtyard house, and this one is in hot and dry climate belt of India. So, here what he does is he blocks the southern facade from where the heat would penetrate. And how he does that is he provides the services on the south side. He provides the pantry, the gents' toilet, the staircase, the lift, etc. on the south side and blocks it. And thus, not only that, the columns are on the periphery, and thus the internal workspace is completely flexible. And there are glass reinforced concrete jalis all around the building, which are in an abstract angular geometry to filter out the heat. Now, one question will arise in our mind: why the south side? It should be the west side. We've always been taught the west should be kept like a blank wall, no fenestrations. He should have provided the services, etc. on the west side. Why doesn't he do that? Because it's an office building, and this is what happens. First of all, like I told you, technology is helping us today. Contemporary softwares have enabled the study of the solar path to be able to understand sun penetration inside the building. As a result of that, this is how the morning solar path is. This is how it is in direct light throughout the day. And so somewhere, let's say in the middle of the day, the sun will be coming through like this, and this is how it will be in the evening. Now, please understand this. In the evening, the office mostly will shut off. People will go back home. The work time for most people will be over. As it is during this time when we require maximum thermal comfort. I mean, we want to keep out the heat gain from this side, and that is the southern side when the work day is at its peak. And this is what it is doing. And the other thing is, because of the jali, very interesting light patterns are created within the building. We'll have a look at that later. So, if you watch it very carefully, in this segment shows us that the light, the sunlight is not able to penetrate into the workspaces from this side. Now, the glass RC jali envelopes around the building, and it is a direct derivation of the jalis of Rajasthan, inspired from them. So, this is the jali, the way it's been used in Rajasthan Haveli. This is how it is. And so, this is the computationally derived jali in glass reinforced concrete. And this is the sciography it is creating within the building. It is an abstract folded plane which is mounted on a steel framework, as you can see here, and it was designed and assembled using computer technology, and it is an important climate responsive feature of this building, thus preventing heat gain from all sides and also increasing ventilation, because the wind flows through the jali and that increases in velocity and thus that is good breeze that penetrates into the building. Because of the jali, the building becomes energy efficient because reduction of heat load. Also, it provides you better daylighting without the glare, and so that reduces the lighting load also. Now, here is how the cooling of the building is, the cool air is penetrating into the building. The other thing that happens is that between the jali and the interior of the building, they have provided these plants within that space, and that also serves to create cooler office spaces. So the screen creates this pleasing ambience with the sun streaming through, and this is a kaleidoscopic sciography that happens within the building. Now, architect does not neglect the architectural or the aesthetic component. The trapezoidal planar geometry that is reflected in the glass RC jali work continues in the interior, in the ceiling, in the counter that has been created for the receptionist, and in the layout of the furniture within. So the trapezoidal geometry is consistent throughout the building. It is very similar to the way in which F.L. Wright used to use geometry. He would build the entire project on one geometry. If it was triangles or pentagons, the entire or hexagons, the entire geometry would be built around that polygonal shape. So this presentation primarily focused on why there is such a great need of climate responsiveness today because of carbon reduce for the need to reduce carbon emissions, and also the great advantage that technology is giving us today to modernize or use traditional systems in a much more efficient way in the buildings of today. In the next presentation, I'll take you through some more studies, and we will look at how other architects are responding in other climatic regions. Thank you.